Okay, fine.
Can you give host permission to you?
Can you give the host permission to HackDuke a DK account?
Okay, hello everyone. This is Mustafa Misir from the Kunshan University. Today in this talk, I will be discussing machine learning a bit and try to give you some hints how to implement machine learning in this kind of scenarios like this event, and what kind of application would be suitable to work with machine learning. And I realize that you have been discussing that already, so maybe there will be kind of an overlap, but I hope it will still be useful. Before telling you about the machine learning, I would like to tell you what is AI. Of course, there are a lot of description of the AI, but the simplest one you can get would be mimicking human actions and thinking and behavior. So any system doing that, which will be considered as an AI system. And AI is not something which, like, people studying in academia, like they're doing projects at universities or publishing papers, but it has been a kind of an active research area linked to patents, and they have been used in products. And this one on this slide, you're seeing different companies and universities, research institutes providing patent applications. And these are the top ones. But the topic of today will be machine learning, and machine learning is essentially a subfield of AI. And these days, if you're seeing some news, some fancy applications telling you it's AI, they mostly talking about machine learning. And underneath, we also have this deep learning stuff, which is essentially a family of machine learning algorithms under neural networks. So again, many of those leading applications come with deep learning, where you can utilize a lot of data and learn some patterns out of it. And what do we mean by machine learning? It is pretty simple. So what we want to do is we want to make computer to be able to do certain tasks without explicitly programming them. And those tasks are usually the ones which are complex to identify formally. For instance, like I'm speaking right now, it might be easy from my perspective, but it's not easy to formally describe how to speak or how to understand from the other side. So what we basically do is we provide some amount of data and process that and try to learn patterns, how to speak or how to recognize the speech. And to give you more examples, we have been using machine learning already in our life. And one particular example, the first one I want to give is spam filtering. So as everyone is using emails anyway, so some of our emails go to a folder called spam or bulk or junk. So what basically does is they have this system which process the delivered emails, and they identify whether it is spam or not. And how to do it, they already have some emails which are spam and some emails which are not. And they try to explore some patterns out of those data. And whenever a new email arrives, it detects or determines whether it's a spam or not. If so, it sends it to that spam folder or the bulk folder. And the other common example we have been seeing these days is recommender systems, right? So these days, everyone doing Google search or Baidu search, having advertisement based on your the website visits. And we are using platform like Netflix, recommending us movies to watch, and or things like Spotify, suggesting us some music to listen. Or we want to buy some products like on Taobao, and it is telling us what kind of products would be interesting for us. Another common application field, which is linked to speech recognition, natural language processing, and translation of the language from one to another. And there are many products doing that. I will touch that to this one later on as well. Face recognition, this is also kind of a common thing with our phones, right? We log in our phones by using, they unlock our phones by using our faces. And there are also payment system allowing that. So this is also another interesting application of machine learning. And lately we have autonomous cars, right? They have using a lot of machine learning in it. So because they need to learn, they need to address a number of different learning tasks, and they need to come up with different machine learning models and combine those decisions and come up with an autonomous driving experience. A gameplay, right? So I assume some of you like playing games. And now we have the machine learning doing that. And it can do better than humans. And the other stuff, right? So this is an example from Google. Maybe you know the Google Pixel phone. So when it came first, it was actually the phone which taking the photos the best. And they had like a single camera lens while the other ones having multiples. And the point was mainly to have, to provide that bokeh effect, right? You take the photo and you see the people or the objects you want to take the photo of, and you blur the background. And they basically do image segmentations, and they were doing better than phones with multiple lenses. Finance, right? If you have some money, you want to invest, make some money out of it, and you need some advice, right? And machine learning can also do that. But how can we do this, right? There are many different ways, but linked to also this event, this hackathon, and I would like to introduce you some of the things you could have been using. If you're especially trying to come up with mobile applications and you want to include some machine learning applications or capabilities in it, you could go with existing libraries already doing that. And one nice example is a Google ML kit, which already provides you a basic models which can do the common machine learning task you want to include in an application. And these are useful from different perspectives. One is building usually like a good models could take time. So you might need some computation power, and you need to accommodate a lot of data usually. Because they're already done, in this case by Google, you can directly take them and use them in your application. And by the way, with this one, you can implement the application for your Android phones or iOS phones, which is pretty simple. And I don't know whether you can see the links, but there's a link of ML kit, or you can do a simple Google search and you can go to the website. You're going to see a lot of examples. It tell you exactly how you can do that. And if you're like an iOS person, I want to do in that area, and they also have similar stuff, right? So they have this Apple Core ML, and you can also see it on the slide. They do computer vision, natural language processing, speech recognition, and further analysis in the sound. But if you're a guy who is more interested in the programming side, you want to touch the machine learning a bit more, and there are libraries to work with. And the simplest one is Scikit. Maybe you're familiar with it if you work with machine learning. It allows you to build models with a few lines of code. But if you're a bit more serious, you want to inject a lot of data and especially utilize deep learning, and there are many more libraries to work with. And of course, mostly they already give you the backbone of the application. You kind of just combine them in a programming setting and train them with the data you provide. But giving a bit more details on this kind of system, I would like to refer to the Google ML Kit. And they have different kind of application. They are already implemented. You can just take their API and connect it and just put it into your application. Like you can do barcode scanning. This is the vision API. You can do face detection. You can do image labeling, text recognition, object detection, and tracking, selfie segmentation. You can pretty much do everything with that. So basically, you again, as I said, you just go to their website. They explain how to do that with some examples. You can easily include this kind of things into your applications you're developing. And to further give you a bit more examples, and they have this GitHub link, which is linked to the Google again, and they provide the code. You can directly get and run it. And here are some examples. The first one is like a labeling birds, right? Telling you what kind of bird it is. And the second example, you were saying a mobile app, which is doing just object detection. And third one is also even interesting one is doing pose detection. So maybe you want to do an application, which is doing things like a fitness tracking. You know, you have a device at home with a camera on it. It can tell you whether you're doing the moves correctly or not. And the other super common thing they have been including in many other applications is the natural language processing API under Google MLKit. So if you write some text, it can tell you it is from which language. It can obviously do translation via Google Translate. It can even do reply, so you can use like a chatbot and many other stuff. And this is one example to show you this is really used. Like, I don't know whether you know WPS. Yeah, they're used more in China, I believe. I don't know whether it's as popular as outside, but this is like a bunch of office apps, right? It's pretty handy. They also use MLKit. And according to what they say, they're saving a lot of money by using these MLKits instead of developing them by themselves or buying from some other company. And now let's refer to the themes of this event, right? And I believe you're discussing things on inequality, health, environment, and education. I will try to give you some kind of example application you can pursue. The healthcare is kind of probably one of the most critical commercialized application domains of machine learning. And if you want to be rich, I assume some of you want that, you can go with an application in the healthcare. Because I know that there are a lot of people, they just write there like a thesis and convert it into a product and with a startup company. Some fail, some become successful, but if you're becoming successful, you can make quite a good amount of money. There are different ways of doing it, different kind of target areas. One is diagnostics, so you can diagnose certain diseases. Or the other thing, you can come up with a treatment plans automatically. Or you can do population health management, like the issues we have faced with COVID, right? We had to come up with kind of policies, how to deal with that, and machine learning is helping that as well. And also you can do administration like in a hospital environment, right? How to make it more efficient or etc. And if you're interested in this field, I specifically suggest you take a look at this book. This is a pretty nice book, which is easy to read, and it's telling you some examples and how it can be useful, involving machine learning in the healthcare setting. Now let me show you some examples and show that machine learning is really a thing in healthcare. I don't know whether you're familiar with this stuff, but one thing I want to tell about radiology, I assume you went to hospital to take some images for that, at least most of you, I guess. And this is probably the most common application domain in medical field by machine learning, because you're having these images and you need to process that. And the purpose of the radiologists they just look at the image and they write a report about it. You know, they tell there are this kind of problematic tissues or what kind of diagnosis they have by looking at the images, but you can do them automatically. And this one is an example I put up here. It already tells you that with machine learning, you can already outperform radiologists in terms of your quality and in terms of your speed. And pathology, if you're interested in that stuff, you know, you take some cell examples, you put up maybe under microscope and try to identify whether you have certain disease or not. And this is, for example, with cancer. And again, they show that they actually get comparable performance to the expert pathologist and faster. This one other example, but new linked to the dermatology, where they look at the diseases on your skin, right? And this one specifically for cancer again. And they show that they can come up with a machine learning model which can do as good as expert dermatologists you could find. Ophthalmology, which is another interesting field to work with. This is a disease with your eyes. and is linked to diabetes. If you have anyone have diabetes, you might heard about this one. This can make you blind. So this is kind of an important one. So detecting it is really critical. And so they came up with, this is one particular example again, just come up with a machine learning model. But as you can see, they're utilizing a lot of stuff like 130,000 images. This is the medical photograph of eyes, right? And they try to predict the stage of the retinopathy so then they can prevent the blindness. And yeah, they again came up with a performance which is like as good as experts. Cardiology, which is probably something you're familiar again, right? And you have this electrocardiograms and they're showing you kind of the signals coming to your heart, right? Like kind of pulses. And they have over 500 data points, not too big, but they come up with a system which can detect heart attacks. And again, comparable with the cardiologists. But of course, we also see this kind of application now with our like a smartwatches. Maybe you know that. They already kind of monitor your state and they tell you this kind of stuff. And again, they're using machine learning to do that. And yeah, many more. Gastroenterology, which is another thing, which is also linked to cancer, and they show comparable performance to the experts. So as I told you, that you want to be rich or not. So this is kind of evident. So telling you a lot of companies, and I believe most of you are the startups, and they start small and they grow big, and so. After we get your contractor, so it's just getting better and better. And if you get too good, then probably some big company will purchase you. So, but to show you this is really important, and this one is studies example from Google. Okay, so they do search engines, right? Maps, emails, but they now also do healthcare. They're coming up with the system which can do diagnosis or treatment plans in medical field. So it's an important field to go in if you want to do an application. Yeah, that was the examples I gave in the healthcare field. Now I want to talk a bit about education, right? What kind of things we have. So probably you came up with some tools in the education field, and there are a number of tasks in the education to use cases of machine learning. One is planning like a kind of a teaching curriculum or the question, because like you're using this kind of tools, which I'm going to show you some examples. It gives you the question suitable to your level. And based on your answer, it gives you a suggestion, what did you do wrong, right? And it also elaborate, because it's not like a tool you just go to a computer and just give an answer and get your score. It should be beyond that, like an instructor, like a university setting, right? You further ask, what is wrong with that? Why my answer is wrong? And you give the answer, maybe it's not good enough, right? You ask further, and it keeps giving you more feedback, so it directly interacts you and behave like basically a teacher. And yeah, so there are a lot of companies, and they usually called inside this ed tags. So you can also find many of them. I will give you a few examples. And this one is just a virtual assistant, which is more like like a chatbot. And they're actually benefiting those existing chatbots. I don't know whether they use ChatGPT. I'm going to talk about that later on, but they benefited those kind of systems. So you kind of ask questions about the topics you're studying or whatever, and it gives you the answers which is required to you. But of course, this is kind of tools we don't like, because you want to do your homework, you kind of get help from these guys, and they do your homework for you. But yeah, they are there. So. And this one, maybe you know Duolingo. Yeah. I also use it. I couldn't focus on much yet. I hope I can improve my Chinese over time. But this is one nice application. It is giving you like a question, giving you a task depending on your level, your answers, your performance, right? That's kind of one thing. But lately they come up with an extension called Duolingo Max, which is involving ChatGPT in it. So you talk, you further ask why it is wrong, you elaborate on that, give a better answer, convince me, right? Maybe you think what you say is correct, but it tries to also explain you in detail what was wrong and what was right and why. So that's why I would like to point out, if you want to do an application and this kind of system like ChatGPTs, and there are now many more similar purpose environmental libraries you can include, and they can be pretty useful because you don't want to develop this kinds of system by yourself. As I said earlier, you need to inject a lot of data. You need to train it really long time. You may need to really a lot of computation power to work, and maybe you don't have any of them. And there are already ones which are built, right? And this one with ChatGPT, I already put up the link. You can develop an application just connecting with ChatGPT, and again, like they did in the Duolingo, you can also do that. And there are many more applications doing this kind of stuff. And this one is another example. I think this is for kind of kids math and Teamster math. And you kind of solve it. Again, it tells you what is wrong and give you like more suggestion and giving you more explanatory answers, as well as giving you question based on your level and progress. Okay, let's move to the environment, right? So this is kind of an important stuff lately. We have this climate crisis, climate change, and you're seeing there's fire everywhere, there's flooding everywhere, there are earthquakes everywhere, right? It's kind of a disaster. So I don't know whether we can solve it, but machine learning has some kind of use cases in this area as well. And yeah, there are a lot of applications actually. So, and if you're interested in the area, I would like to also take a look at, as the keyword, you can take a look at environmental data science. And they try to solve machine learning, using machine learning to solve problems in the environment related tasks. Let me give you a few examples. But before that, I would like to tell you that one kind of particular focus in the environment is linked to remote sensing. So what they basically do is they look at, this is mostly based on imaging, and they take this imaging and they process it and try to come up with some conclusions, predictions, and plans. One example I would like to tell you is this one. This is actually a common application nowadays used by governments or local municipalities. And they're utilizing those satellite images, and they try to tell, what is available on the image, right? I don't know whether you can read it. It can tell their buildings, their trees, their grass, right? Whatever. And the point here is usually, they take these images for different time periods, and they kind of follow what is really changing, and if there are some illegal kind of construction or etc., this kind of things have been used in this type of applications. But more towards to environment area, more like really the environmental issues, things like deforestation is kind of a focus in here. So what they basically do is, again, they do this, they do satellite imaging, and they take this at time-based satellite imaging, and they try to make prediction whether there is deforestation or not in the long term, and so that you can kind of take precautions to prevent that. But lately, of course, this satellite images, probably you don't have satellites, right? So then you can get help things like Google Maps, Baidu Maps, and use their images. They also have like APIs to access those data in a program or in an application. But lately now, people move to the unmanned aerial vehicles or drones. They take images with them. So now the application is a bit goes that area. This is another application. Lately we are seeing this kind of attacks or problem with the leaks, right? Especially happening in, of course, the seas or oceans. But this one is an example on the land side. You located some some pipelines underneath, and if there's some kind of construction, you monitor them and you kind of warn these guys, okay, there's a pipeline underneath, be careful, don't mess up with that, right? And one last thing I want to talk about, the exemplify with respect to environment is cleaning. We are seeing that water has been filled with garbage and other stuff these days, and now they have this kind of autonomous garbage collector, which is basically like a small ship which collects the garbage by itself and put inside and hopefully clean many places as much as possible. And they have this pilot studies in a few other countries and doing this. So I don't know how it will work out though. Yeah, that was the last thing to talk about in terms of environment. Now I would like to touch the inequality as the last theme of this event, right? But before talking about the inequality application, I would like to tell you that inequality is actually an issue within machine learning already. I don't know, maybe you have seen different kind of issues. For instance, there were some applications some while ago, like they do face detection. If you're coming from a certain race, it doesn't even recognize you. But usually those kind of things link to the data you provide, right? If you provide data which is kind of diverse enough, and you can come up with a system which doesn't do this kind of inequality or this kind of issues. But the inequality mainly in the sense of machine learning is referred to the economy more, because with the machine learning, the thing is we are automating more stuff, right? So it means that this is kind of one of the concerns, right? They say that it is taking over other people's jobs. Yes and no, it is also producing more jobs, but the problem here is people are discussing when they're taking those kind of a simpler jobs, the people with kind of a less amount of education, they're kind of excluded from the work environment, or if they need to find a job, probably they will find something, a low paid job, because it is already kind of cheap if they use machine learning. So, and if you're, of course, have like a higher education, I heard that you have been discussing going graduate school or whatever, and you can work in like a high-tech company, you can get quite a good salary if that's what you want, or having your startup and make a lot of money. But so this is kind of causing this inequality just by machine learning. So that's kind of an issue. But if you want to look at kind of the good side, we can use it to identify the inequalities and come up with policies to address that. And this is one study I want to notify you from UK. And what they do is they provide data in terms of like income, health, crime, housing, and living environment. And also they use images taken from Google Street View. And they combine that, they identify inequalities between different parts in UK. And the point is, I don't know whether they can take any action on this, but kind of identify that and take some actions how we can kind of equalize or make the gap smaller between those different regions or districts. And the last example I want to give you in this inequality part is accessibility or service quality. The one example I want to give specifically in the medical field, we already talked about. This kind of thing is the medicine especially is highly important. Especially if you have money, if you're living in a big city, it might be easier for you to reach a kind of a good or famous doctor, right? You probably get a better service. But if you're in a rural area, maybe you don't have enough money, right? It might be a bit hard to get same level of medical service. So again, this links to your location, this links to your income, or maybe you're coming from a group which is socially excluded in the particular country. So with the machine learning, you can kind of balance that. And I already give you examples in the medical field. You can come out machine learning systems which are at least as good as the experts in a particular field, and sometimes even better than them. They're faster, they're better. And so, and these are the things usually like tools. You don't usually put a machine learning system and use it as a medical device. So like a doctor is using it. It's just using it as a tool and getting kind of an idea. But still the doctor is the one deciding the diagnosis or the treatment plans, right? So that's why you think that you have really an amazing doctor with a lot of experience. And there's a doctor which is just newly graduated, not much of an experience, but this guy using a tool, and it kind of put this guy, the kind of a low-end doctor, to the high-end doctor level, and you can give this accessibility or service quality across different regions, providing somewhat equality in that sense. Okay, to finalize my talk, I would like to briefly summarize the benefits and the disadvantages of machine learning. And the first thing we get, if you develop an application involving machine learning, you're going to get fast decision making. So you tend to give decisions better than human, right? And probably you're going to do less errors. Maybe, again, just to give an example from doctors, you had a really a rough day, you had your own problems, you have seen a lot of patients. Now patients come through the end of the day, you couldn't even focus on to the patient, and maybe you give like a wrong decision. So with machine learning, you can suggest less errors. But of course, you should keep in mind that because machine learning is learning, but it's not really learning in a way. So that's why it can also do stupid mistakes a human wouldn't do. So it is doing less errors, but it could do certain stupid mistakes human wouldn't do. And also referring to the last example, it can give you standardization. You know, the equality kind of could be served in a certain way. And objectivity, right? Again, maybe you're a doctor and you hate the patient, right? Asking a lot of questions. Yeah, a computer won't mind that, right? So, and high quality services, which is also linked to what I sold, and they can work 24/7. You know, they don't ask for a raise, or they don't ask, you know, I work too hard, raise my salary, right? So that's kind of the nice parts. But of course, life is not that amazing, right? We also have problems. One is unemployment. And as I told you, if you automate certain process, and some people laid off from the work, which is you cannot avoid. But of course, and at the same time, it is offering new jobs, right? But as I said, it could be, people should be careful about it because it is suggesting inequality. Like kind of the people who don't have much of an education, maybe they they can do the jobs which could automate it. So then probably it will be hard for them to find jobs, or they can find jobs with really low payment. The other thing to take into account is laziness. Again, let's refer to the doctor aspect. You know, if I'm a doctor, I'm using this application a lot, and I see that it's really doing a great job. And maybe after a while, again, maybe I'm tired. Okay, let's trust the application, right? But maybe it gave a wrong decision, so they should be careful. And this one is kind of lately people have been working on, which is the explainability. You know, you come up with a system which is really working well, but people still wanted to ask, you know, why this is working well. Maybe you said, you know, you have cancer, and you know, to explain why you're saying that, right? You know, to have convincing argument, and people studying that. And the other things, you have machine learning involvement, and you need to think about ethical and legal concerns. One side is the use of data, right? Maybe you're using data without the will of other people, so you should be really careful. Or maybe something bad happened because of your machine learning app. So who will be responsible? Like the autonomous cars, right? You made an accident, someone died. Who is responsible? The company, the driver, autonomous system, right? Who will pay for it? And the last thing to mention, the issue with the machine learning is something called red AI. You know, they are having those really fancy applications. They do super well, and they do better than human. But usually the problem is you need to train it really long time. Like maybe you have seen the examples, things like AlphaGo, right? The machine learning system playing like a crazy Go, right? Really amazing, better than the champions. But to train it, you need to spend like millions of dollars just to train it. So, and people are kind of in a race right now. They try to come up with the best of the best, but maybe not really all of them it turn into a real use. So people should be careful about that, which could lead to this environmental impact. So you come up with a model, and just training it kind of is equal to maybe the lifespan of many cars in terms of the carbon emission you're releasing. Yeah, that's all what I want to talk about. So if you have any question, please let me know.
Yeah, Nazir John has a question.
Thank you, Professor. I wanted to ask about, as we look to the machine learning as a sort of rocket and data for like fossil fuel to it.
Yeah.
And what do you think the idea about synthetic data? Because in the majority of cases, we are not able to provide that data for to train really good models. And what do you think about synthesizing data for these particular cases?
Yeah, that's a very important question, and I want to answer with an example. In the autonomous car, I don't know whether you have seen one. Of course, you're seeing Tesla around, but I don't know whether they're running autonomously in China. I'm not sure. But there are already applications. In US, there's this Waymo company, which is a sister company of Google. And in China, they have Baidu. And they generate two sources of data. One type of data is the real data. Like, I don't know, Baidu, I think they work either in Guangzhou or Shenzhen. I'm not sure. They have actually a taxi service. You can use Baidu Taxi. So the whole point Yeah, autonomous. But usually they keep one inside. So there's some one inside. It's for safety. And I think in Guangzhou, they also have like autonomous bus following one route.
I heard also.
Yeah, these are kind of the places you have these tech companies. Yeah, possible. And what they do is the idea is they're collecting data. They try to face different scenarios and collecting data and so that they can improve their autonomous driving experience. But the other thing they do is simulation. So what they basically do is they kind of provide a game-like environment, like a computer game. So you drive the car autonomously and you identify certain scenarios, maybe like a dog running through road, what you're going to do, things like that. And they learn out of that more. And of course, as you can imagine, the real data they have is substantially small compared to the one they are collected in simulation. So this is of course used, but there are also like things like generative networks. Maybe you know it. They are generating data. They have been pretty successful, but still they need to have hint of real data. So, and also they have areas like semi-supervised learning. I don't know whether you know this different learning problems. And in that case, they usually have small amount of labeled data, but a lot of unlabeled data, and they still come up with good models. And especially in the medical field, this is a problem. Like in the radiology, I know these companies, to be able to get the data, they need radiologists. They give them maybe just radiology really write a report or whatever. So it means that collecting data is super expensive. So you cannot just say, I collect data for everything. So that's why we definitely need that synthetic data one way or another. Yeah.
Yeah, one comment I would like to add. So when I was taking computer vision class, there was such technique that we would use to synthesize data.
Yeah.
Data augmentation. It's basically changing the existing data, for example, rotating it or flipping it or zooming in, zooming out, stuff like that. And you multiply your data by how many times you want. Yeah.
Yeah, but that's also useful with respect to the machine learning algorithms, because some of the algorithms, like maybe you give an image of like a dog, like a normal one, it can detect, but maybe when you rotate it, it won't detect. So it also provide that, enhance your model. Yeah, good addition. Yeah.
Thank you, Professor. And you've mentioned a website called Google Machine Learning Kit.
Yeah.
Actually, I'm very interested in machine learning, but I have little background of computer science. Actually, I'm majoring economic and
Okay.
I'm really wondering if there's a tutorial or some books that to learn it from scratch. And by the way, my math is very bad, so I'm looking for something that is like application oriented instead of theory.
I mean, one thing, like you don't need to be a math expert, but better to know math, so it's useful for everything. That's one thing. And the second thing, to develop machine learning application, you don't need to be an expert in machine learning. Like he mentioned, he took a computer vision course, right? Probably he can deep dive in the algorithms. He can change them and come up with models. But we're running now. So you can do that. But apart from that, this kind of tools like Google ML Kit, by the way, I put the links. You can see that they have examples and tutorials. But if you like the book, I suggest you to take that book, which is a book written by someone from Google. So it's very nice and simple. So you can take a look at that. You don't really need to know like an expert in programming, but I suggest you should know some programming, okay? That's one thing. And the second thing, if you're really like a bat, you have no idea these kind of stuff. I don't have an example, but there are tools for this kind of people. One example is the Azure ML. Do you know that? It's by Microsoft. What they do is they give you a website, you have no idea about machine learning. You just do the basic stuff. What you do is you have these boxes, you just connect them, like make a flow chart, put your data and say run, it's going to build the model for you. So it depends. Yeah, they have a lot of things, but it's very like handy. So it depends on what you want to do. And also Uber, I think they also have like a deep learning library, which is super simple. So you don't need to be an expert. So which someone at your level should be able to work with that. Yeah.
Thank you.
And if you're interested in NLP, I think there's now Google Bard API and very nice interface inside Google Cloud, which you can use also to build your own model.
Yeah, Google Bard, by the way, is a kind of the rival of the ChatGPT. Yeah, doing kind of the same stuff.
They investing so much. They're like, they woke up literally.
Yeah. But they're fun. I see some students also, of course, don't do that, but they're searching programs, like how to write, I want to load file, how to do that. And search ChatGPT gives you how to write that. So it's really fun. Yeah, any more?
Okay, I have a bit of more general question.
Uh-huh.
Machine learning versus deep learning in computer vision.
Yeah.
So generally, I think I have heard different opinions. That's why I'm asking. Some people say using just regular machine learning is sometimes better in computer vision than using, deep learning, which is like bringing tank.
Yeah.
I don't know, open a door.
Yeah.
Yeah. So what are your opinions on that?
Okay, one general answer is, it is true. Deep learning is not the answer to everything. Because if you're using deep learning, you need to give a lot of data. If you don't have a lot of data, maybe you don't need that. And the second thing, you need to really train it a long time. If you're not doing that, maybe you don't need deep learning. That's one thing. And the second thing, their application, usually just pure machine learning is better. Like I remember this startup company I visited some years ago. They were in finance. They were doing some prediction. They said that, we picked up this kind of fancy deep learning architectures. We were using it, but then we turned into like a simple ones. Then we ended up using things like random forest. It was just good enough. And it was faster because deep learning has kind of problem, like they have this problem, especially in like autonomous cars. Like you need to make future prediction, right? There's a car in front of you, what kind of behavior this car will show. You need to predict that. So this is kind of what they do is, but sometimes the prediction takes time, right? If you're using a regular machine learning algorithm, prediction is super fast. But deep learning, maybe you need to wait, I don't know, 2-3 seconds, maybe, then maybe 10 seconds, maybe 30 seconds. It depends on what kind of model you have. So maybe it's not even realistic in some cases. Then you need to go back to the regular machine learning. And for the computer vision, I believe that deep learning has like kind of more chance because you're dealing with, this images, and if they are like high resolution, like in medical field, like I told you, radiology, and they're working with the images of size like 1 gigabytes, one image. So you cannot just deal with that with a normal machine learning. It won't be able to capture that complex relationship. But at the same time, depending on the application, like maybe in your computer vision application, it's not that super complex. Then you can kind of have because and sometimes you don't work with the data, like the full data, but you kind of simplify it first. For instance, in the image case, you maybe decrease the resolution, make it smaller. If this is good enough, then you can use those traditional machine learning algorithms instead of going after a deep learning. So yeah.
Okay.
Yeah, I actually had the same situation. I was doing like prediction for my machine learning class, and turns out that I spent some time designing a neural network.
Yeah, that's also a problem. Like, yeah.
The random forest does a better job.
But usually in principle, deep learning neural network will do better because more flexible. But the issue with the deep learning and neural network, they have hyperparameters. So you need to find that right setting. And now that's why they have this automated machine learning tools. If you go Amazon, Microsoft, Google, they all have. So because defining a good network is not that easy. So that's why, you see those papers they are giving you, but they actually tried many networks already. It's not the first network they tried. Probably the first one failed, right? Like also in your case, maybe it was good enough, but you couldn't find that setting. And the other one was easier in terms of those hyperparameters, then it already solved your problem. Yeah, this is kind of what they are doing. And all big companies, they're providing services on the cloud. You can do hyperparameter tuning. Yeah.
Any other questions, guys? All right. I think no questions from online as well.
No.
Okay. I think, yeah. Then, do you have anything else to
Oh, no, that's all. So yeah, thank you then. So see you another time.
Thank you so much, Professor. What's next?
He's very
2 p.m., right? So we have oh, we don't have break. Thank you so much. Yeah. See you later.
See you.
So according to schedule, next what we will do is judging. So if any, all the teams are here, right? Raise your hand if you're a team leader. Okay, we have one team. Where's the second team? Are you one team all? Okay, why are you sitting so far away from your? Okay, so we have 2 teams. Where's the third team? There's 3 submissions. Oh, you're a third team.
I'm not the team leader.
But you're okay. Who's team leader? Is she coming?
I'm not sure.
Can you text her in WeChat? Is it her or him? Her. Okay. Yeah. Yeah. Can you text her and ask to come? All right. So we will first review the projects on our own. I mean organizers, and right after that we'll be approaching you one by one, each team, and asking you to give a live presentation of your project. Okay, if you have prepared slides, then you can talk about the slides. If you have no slides, then you can just open the demo or your code and explain what you have built and why it is important. Okay, so you have roughly 15 minutes now. 15 minutes. Please